Alright, so now we're going to look at the equation of ellipse where the center is not at 0, 0. It's at h and k. So h and k could be any values. So we're going to get ellipses that are centered anywhere in the coordinate plane. Okay? So the equation is this. So we have parentheses x minus h squared plus parentheses y minus k squared. The x part is still divided by a squared, and the y part is divided by b squared equals 1, always 1, alright? So the only thing that's different from here is that we put this h and k there. So if they're missing, right, if there's no parentheses with h and k, then h and k are just 0. But if there are values there, then you take those values. So notice the equation is minus h and minus k. So you're subtracting the values of h and k. So when you identify them, you're going to change the sign. So if it's -3, h is going to be +3. If it's -1, h is +1. If it's plus, you have to change it to a minus because those values are subtracted. So you have to write the opposite. Okay. A is still, so procedure is still the same. You graph the center and you move A values to the right and left from the center and B values up and down from the center. Okay, so let's look at this graph. So first we figure out where the center is. Alright, so the H is 3 and the K is 1. Why did I write K? K is 1. Alright, so those are x and y values of the center. A squared equals 9, which means A is plus or minus 3. And B squared is 4, which means B is plus or minus 2. Right, so we're going to graph the center at 3, 1, right here. Alright, and from here we move 3 units to the right, and 3 units to the left, 2 units up, and 2 units down. Okay? And we can write the coordinates of our vertices. You write the vertices are the ones at the end of the major axes. Those are sort of more important. You can see that we have the x value is 6 and the y value is 1. And here the x value is 0 and the y value is 1. Okay? So we can draw this ellipse like this. There we go. Okay? Awesome.